Okay, we're going to move on to the next example. It's a slightly more advanced question. It's not a simple rectangle anymore. You're actually going to have to draw a parallelogram, okay? Because the forces are at an angle to each other that is not 90 degrees. Okay, but the steps are exactly the same. So actually, I would say please try this on your own first. Unless you're really confused, you're really lost, then come back to this video. Or if you're done, you can use this video to check. Okay, so yeah, so let's see if you can remember the steps. If not, you can have it beside you and refer to it. The first step would be estimate, right? Estimate where the resultant force is going to be. So the resultant force, remember, it's going to be somewhere between the two forces. And if it is upwards, this one is a bit longer, so it's going to be a bit more upwards, right? So the resultant force is going to be, if you were to estimate it, it's gonna look something like this, right? It's gonna look something like this. So your diagram, you're gonna get ready, it's gonna be something like this. Okay. So step 2, choose a suitable scale. So you look at the space that you have. You're gonna need a 5 Newton force upwards and a 3 Newton force downwards from the origin. So if your origin is here, you're gonna go one up, one down. So you just look at how much space you have. Yeah, so I'm just gonna use the same scale as the previous question, which is 1 cm represents 0.5 newtons. Okay, I probably should have chose different numbers. Yeah, so next, draw your origin. After you chose your scale, write it down, then draw your origin. Okay, so I'm gonna draw my origin. My origin needs to be somewhere here because I'm gonna have one up, one down. So you just draw a horizontal dotted line first. Okay, then I draw a vertical dotted line. Remember the hack that you can use this marking to get your perpendicular line, but try to use the long one so that you have more line to go with. Then okay, this is your origin. Okay, next step, draw in the two forces from the origin. So now this force is 40 degrees from the horizontal. Can you see? The 5 Newton force is 40 degrees from the horizontal. So you use a protractor, you put it at the origin. Right? So nice and accurate. 40 degrees from the horizontal means from here, 40 degrees. Right? Oops. Okay, not great planning on my part again. So at the end here, remember to draw the arrowhead. Okay, and this is 5 newtons, right? 10 cm, 5 newtons. Next, this is 20 degrees below the horizontal. So if it's 20 degrees below the horizontal, same thing. You just put the protractor here at the origin, and you go 20 degrees below the horizontal. So right here is 20 degrees, and it's 3 newtons, so it's going to be 6 cm. Alright, so from the origin, 6 cm, 6 cm. With the arrow, 3 newtons. Okay. Next step is you construct your parallelogram, right? So of course you've checked, you've drawn the arrow. Okay, wait, sorry. You've drawn, you remember you need to check 3 things, right? Arrowhead, force. You need to put in the angle. So this is 40 degrees, this is 20 degrees. Okay, put in the angles. Next, construct your parallelogram. So get your sail ready, align it such that it is aligned with this. Okay. So the vertical part of the sail is aligned. Take your boat, flush it with the bottom perpendicularly. Okay, sorry, so you need to hold this properly first. Flush it, hold your boat steady, and then slide your sail. Okay, slide your sail to the end of the other force, and then draw a dotted line. Okay, I'm probably going to need to extend this line. So one way to extend this line easily is actually the same idea. I line and then I extend. If not, you can just extend it normally like how you extend a line. Okay. Okay, maybe just a bit more. Okay, next, you take this one, align it with this force. Okay, make sure it's quite accurate. Put in your boat, flush it with the bottom, slide the sail. Okay, and then dotted lines. Remember, parallelogram drawn with dotted lines. Okay, so you see, now I have my resultant force, right? Where's my resultant force going to go from? From the origin to the opposite side of the parallelogram. So you see my estimate, it looks quite accurate, right? So this is the opposite side of the parallelogram. This is my origin. I'm gonna draw a line, solid arrow. Okay, you gotta know that I'm drawing very inaccurately because I have this whole contraption here, so I have a lot of parallax error. Okay, so when you are drawing, I don't expect to see all these kind of mistakes. It's gonna, yeah, but I'm not gonna redraw that. So double arrow. Alright, so this is your resultant force. So what are the two things you need? You need the magnitude and you need the direction. So for the magnitude, you measure the length. This length is about 14 cm. So if 1 cm represents 0.5 newtons, then 14 cm will be 0.5 times 14, which is 7 newtons. Right, so I got this to be about 7 newtons. And then what is the direction? Again, you put a protractor at the origin, and then you just measure the direction. Okay, I'm going to use the camera to see the angle. So this would be 10, 15, 16, 17, I'd go with 18. Okay, so it's about 18 degrees. So the final answer, let's write down the angle here. So be 18 degrees. So so make sure you write down your final answer, 7 newtons, 18 degrees from the horizontal. Okay, and then do one last final check. Make sure you have all your forces are labeled. Single arrowhead, double arrowhead. Make sure you have all the forces written down, all the angles, and make sure that these are the only 3 solid lines. Everything else must be dotted.